So in the introduction class, somebody was telling me that you have already finished Java, completed Java, you're a full stack Java developer. So guys, give it a try for the programs. So tell me what will be the output of this or how to solve this. So yes, coming to our conditional operator. So the next operator, what we are going to be discussing is our conditional. So the conditional operator, also called as ternary operator. So another name or an alternate name for your conditional operator is ternary operator. So what is the symbol we use for this operator is a question mark and a colon. So a question mark and a colon is what this symbol of the operator represents. Okay, how to use it or why we are using it. So as you know, for each and every operator, we are discussing why that operator. So what is the purpose of my conditional or my ternary operator? It is used as a simple replacement for my if else. So it is going to act as a replacement for my if else condition. And another important feature of it is it helps to reduce the number of lines. It helps me to reduce the number of lines of code that I have to write for a particular logic. That is the advantage of my conditional or my ternary operator. So what it is doing, it is going to act as a replacement for my if else condition. So first thing, what is this if else condition? What is this if else? So if and else, both are my keywords. Both are my keywords. If is also a keyword, else is also a keyword. So what am I going to use it for? So when I want to design a flow of the program based on a condition, that is, I am going to give a condition. If that condition is satisfied, I want the program to execute in one way. And if that condition is not satisfied, I want the execution of the program to happen in some other way. So there are two ways my program can run. So either if the condition is satisfied, something else. If the condition is not satisfied, then some other thing. So how to write such kind of code? That is, you will have two parts of the program where based on the condition, it will be decided which part of the program is going to be executed. So that is done with the help of my if else. So how I'm going to write it is if I'm going to specify some condition. That is, what is the condition I want to test? So that condition I will give within this parenthesis. So if is the keyword, within the parenthesis, I'm going to give the condition. So if this condition is satisfied or if this condition is true, what needs to be done? What part of my code needs to be executed? So that I'm going to write within the if block. Right, within this block, I am going to write that lines of code. Now, next, else. So when it is going to go to the else, when this condition fails. If the condition is true, if will get executed. When this condition is false, then it will automatically go inside the else block. It will not even go inside if. If the condition is false, it will directly go to the else block and whatever you have given inside of this else, that statement is going to get executed for me. That is how my if else statements are handled. So specify a condition. If it is true, what needs to be done? So when the condition is true, it will not go inside the else at all. So please understand, only if the condition is false, it will go inside the else. Okay, this is what we call as a simple if else block. Right, so now I'm saying my conditional operator is going to act as a replacement for this. So whatever simple logics we have, we can write it using the conditional operators instead of giving it using the if else. Now, how to do that? How am I going to do that? So, how to use my ternary or my conditional operator? So, what is the syntax? Here, you will specify some variable equals to, within parenthesis, of course, the condition, then followed by the question mark. Then, if the condition is true, what needs to be done? Colon. If the condition is false, what needs to be done? Semicolon. So this is the syntax of how I am going to be making use of my conditional operator. So give the specify the condition. If the condition is true, what should be done? And if this condition is false, what should be done is written here. So in a single line, we are going to be completing the code. That is what I said. Here also the same thing, right? Based on the condition, if it is true, what should happen? If it is false, what should happen? So this is same as how my if else is working. So instead of writing it like this, I am going to write it using a single line. So that is the second advantage I said. It helps to reduce the number of lines of a code. So that is another advantage what we are going to be having. Okay, so let us try to understand this with some example. Okay, let us go through some examples. So I'm going to say my program, what it is going to do is, I want to know, read a number and find out whether it is an even number or an odd number. That is the question I'm giving you. Read a number, read a number in the sense dynamic input. And also please remember all the programs that I have given you, you have to solve it using scanner class. Dynamic inputs, do not assign any direct values. Okay, all the 25 program, you need to take dynamic inputs and try to solve it. So please remember this very carefully. And all the programs try to maintain it. So create a separate project. Okay, separate project. Inside that, put a package. And in that package, one by one, just make it as exercise 1, exercise 2, 3, like that. Maintain all the codes. Whatever programs we are giving you, all the programs should be solved and it should be maintained. If asked at any point of time, you should be in a position to show all the programs. Just remember that. Okay, so coming back here. So now you know how to read a number using our scanner class. So that is what we are going to be doing here also. So there you go. Let me use my NetBeans itself. Okay, so first thing, I have imported the scanner class. Now I have to create an object of the scanner class. So scanner class name, object name equals to new scanner of system dot in. Done. So scanner class object created. Next step, read and value. Read a number. So let us just say system.out.println, enter a number. Then I'm going to store this number inside x is equal to s dot next int of. Done. So now what is the question says? The question says to check whether the given number is even or odd. So how to decide whether a number is even or odd? How can I guess it whether a number is even or odd? What is the logic I have to apply for that? What is the logic that I have to apply for that? So any given number, if I am going to divide that number by 2, and if there is no remainder, if the remainder is 0, then it is an even number. If I am going to get a remainder, then it is an odd number. This is the base logic, right? Even number and odd number, this is the base logic. Now, we already know how to get the remainder. Remember our modulo operator. our arithmetic operator. So what is the arithmetic operator going to do? It is going to give me the reminder, arithmetic modulo operator. So what is my condition here? I am going to say if, first let us write it using if else. So how to give the condition? I am saying if x is the number which I want to check. So x mod 2. I am saying there should not be any reminder. So how to verify that? Is equal to 0. So double equal to, remember our relational operator. So what is the use of double equal to? It is used for comparison. Whether the value given by this and this value is same or not. So that is what I'm going to be doing here. Right. So do the comparison. If this condition is satisfied, okay, then it is an even number. Okay. So let us take a variable. I am saying string result. I have a variable. I mean exactly to say I have an object called result, which is of the string type. So here what I'm saying, result is equal to even. If this condition is satisfied, if this condition is true, then what is the result? Result is even. If this condition is false, if I am going to get a reminder, then the condition is false, then what is the result value should be? Result must be odd. Done. So this is my logic. So read the number, check whether the number when I divide it by 2, the remainder should be 0. If this condition is satisfied, it is an even number. If this condition is not satisfied, it is an odd number. So now we have to print our result. So I'm saying system.out.println. There you go. I'm going to say x is a even or odd, whatever it is going to be there in that. So number. That's it. Now let us run this program. So when I execute the program, first thing what it is going to ask me, enter the number. So I'm going to give the number as 45. So 45 when I divide it by 2, I am going to get a reminder. Reminder is going to be 1. So the condition is going to fail for us. So when the condition fails, see where it is going? It is going to the else block. It is saying 45 is an odd number. Right, now run this again. Run this logic again. This time I'm giving the value as 20. So 20 divided by 2. No reminder. So it is an even number. So this is how my program is going to be working. Right. So now this involves some 4 lines of code. How can I reduce this 4 lines into a single line? That is where my conditional operator comes to play. So what is that you're going to do? I am going to say result. The same variable is equal to, what is the syntax? First, you have to specify the condition within the parenthesis. There you go. What is the condition? X mod 2 equal to 0. This is my condition. So, if it is true, what should happen? Even. Then followed by a colon. If the condition is false, odd, semicolon. That's it. So, what will happen here? Yes, the question mark. So condition followed by the question mark. If this condition is satisfied, then this is going to get executed. This is the true part. If this condition is false, it is going to execute this, which is nothing but the false part. See, it is just a warning. It's saying the assigned value is never used. I'm assigning the value. I'm not making use of it. So let us just print it. Same thing. Same print. I'm going to copy and I'm going to put it here. That's it. Right. So have a look now. Writing a code with 4 or 5 lines, I have replaced it with a single line. That is my conditional or my ternary operator. Run the program. So number, I'm giving 78. See, both are producing the same result. Whether I do it with if else condition also, same result. Whether I'm going to do it with conditional operator also, same result. So when it is going to give me a same result, why should I write 4 lines of code when it is easy for me to write it in a single line? That is exactly my conditional or ternary operator for me. Right, so this is a simple example of how my ternary operator is going to be working. Right, okay. Now, the last of the operators, what we have is our bitwise operators. Right, so bitwise operators, what are the operators I have? How many operators are there for me? First is and. We call this as bitwise and operator. Remember, double ampersand symbol means it's logical and single ampersand symbol means it is bitwise and. Right. Next to bitwise operator or same thing. Double pipe symbol is logical or single pipe symbol is a bitwise or. So this is going to be bitwise or operator. Then you have the caret symbol. We call this as a caret symbol, which is a bitwise XOR. So bitwise XOR operator, or we call it as exclusive or. Exclusive or just another name for this operator. Then you have your complement operator. So this is my bitwise complement operator. Tilde symbol. The symbol what we use is tilde symbol. Then of course shift operators. This is a left shift operator. Why left shift? See which side it is pointing to? The left hand side. Hence, it is a left shift operator. And then, of course, right shift operator. So all these together is what I have as my bitwise operators. So this is the 6 bitwise operators what we have. So we are going to be discussing on this only. Right. So let us start first. What is the first thing you should know about the bitwise operators? It is they will work only on integers. So please remember any bitwise operator for that matter, it is going to be working only on integers. They cannot work on any other data type. That is real numbers, Boolean, not possible. Integers means what? Byte, short, long, int, everything. All those things it will work. Now, real numbers, float and double. Boolean, data type name also Boolean. So for those things, it is not going to be working. Now, what is the remaining thing? String. That also will not work. Strings also, it is not going to work. Now, char. What about the char data type? So char data type, remember I already told you, char is always treated as an integer for me by my compiler because of its ASCII value. So bitwise operators can be applied on the char data type. Because of the ASCII number representation, since it is going to be treated as an integer, so it is allowed for us. Okay, it is permitted. So this is a small information that you should know. before going into our bitwise operators. Okay, now second thing is how the bitwise operator works. So please remember, first, whatever is the decimal number you're going to give, whatever the decimal number you're going to give, the decimal number will be converted into its binary equivalent. Binary equivalent value. Then bitwise operation will occur. Bitwise operation will occur. Bitwise operation means any of this bitwise operator, whichever one you're using. For all of it, this is same. Any number you're giving, first it will be converted into binary, that is zeros and ones. And then only the bitwise operation will be applied. So you're going to get a result after that. Then that result will be converted back into a decimal and displayed for us as the output. Decimal, and this is given as our output. Please remember, this is the internal thing that will happen. So whatever is the number you're going to give, that number will be converted to a binary equivalent, and then the operator will occur, and then the result, which will again be a binary, will be converted into decimal and displayed for us. So this is the internal process that is going to be happening for my bitwise operators. Right. So now let us start with the first operator, and I'm going to be discussing about the bitwise AND operator. So how does the bitwise AND operator works? If both the bits are 1, if both the bits are 1, then it is going to give the result as 1. Otherwise, it is 0. That is any other combination. So any other combination, it is going to be 0. So please understand, this is how my bitwise operator is going to be working. So let us try to understand this again with an example. Okay, what we are coming to say, let us understand it with an example. Now, I am going to delete all this. Let us keep the number alone and let me delete all this. This also no. Okay, so I'm going to say int x, y. So these are the two variables I'm going to be taking. I'm going to be saying x and y. So I'm going to apply single ampersand bitwise. Okay, let us give the value. I'm saying x is equal to, let us say 28. Y is equal to, I'm going to say 24. Let us run this and see. What is the output you're getting? 24. So the output that I'm going to get for this operation is 24. How we got this 24? What is the logic behind this? That is what we have to understand. Right. So let us try to understand that. Now, right. So I'm just going to take the help of my converter. I want to convert a decimal number into binary because what did I say? Whatever decimal number you're giving, that will be converted to binary equivalent, then only the bitwise operation will occur. So this is my example. This is the output I'm getting. How this output we are getting, that is what we have to be looking into first. So let us try to solve that. So first thing what we have to do, we have to convert this into a binary value. 28 into binary. So say 28. What is the binary value of 28? This is it. Okay, so binary value of 28 is this. What is for 24? I want to know what is for 24. Again, convert. This is for 24. Okay, so 28 equals to this, and 24 equals to this. Right, so now apply the AND operator. When I apply the AND operator, what is the result I'm going to be getting? So please remember what I told you. If both the bits are 1, then it is going to give you 1. Any other combination, it is going to give you 0. So here 1 1 1. Again 1 1 1. 1 0 0 0 0 0 0 0 0. So this is the answer that I'm going to be getting for the AND operator when I apply. So again, what should I do? The result is converted back into a decimal and displayed to us as output. Now 11000, what is it similar to? I have a doubt, convert it. I have a binary number. I want to convert that into decimal number. What is the value I have given here? 11000. Convert. See what is the number you're getting? 24. So that is your output. That is what you got as a output. So that is how your binary bitwise operator is going to be working. Okay, I have already shared you this link, this converter table link. I already told you how it is done, explanation is given. Kindly go through it. Number conversion is very, very important. So if you are already not aware, if you don't remember your max, go through this. I have shared you this link, so better make use of it. Okay, now coming to our OR operator. On the same number, let us apply the OR operator. On the same number, now I'm just going to say, instead of AND, use our OR operator. See what is the result you're going to be getting. I am getting 28. So what is the result I'm getting? I am getting 28. So let us try to see how. Okay, let us take the same thing. So now I'm going to apply the OR operator. So when I apply the OR operator, okay, your bitwise OR, how it is going to work? If any one of the bit is 1, okay, no need for both the bits. I am saying if any one of the bit is 1 also, it is going to give me the number as 1. That is, if both the bits are 0, it is going to give the result as 0. Any other combination, it is going to give it as 1. So for any other combination, the result is going to be 1. Right. So now here, what will happen? 1 1 1 1 1 1 1 0. That's also 1. Because I told you any one bit is 1 also, the result is 1. So 0 0 0 0 0 0. So this is the result number you're getting. Again, convert this result. Convert this result into a binary decimal value. See what is the number you're getting? 28. So that is the output. So this is going to give you 24. This is going to give us 28. Now, coming to our exclusive OR. Okay, coming to our exclusive OR. What is it going to do? What is the exclusive OR going to do? Or bitwise XOR operator. So bitwise XOR operator. If both the bits are same, if both the bits are same, it is 0. Both the bits are same, it is 0. If the bits are different, so any other combination will result in 1. So what I'm saying, if both the bits are same means what? 1, 1, 0, 0, 0, 0. So when both the bits are same, it is going to give me 0. Otherwise, it is going to give me 1. Right. So now let us try the same thing here. Let us write the same thing for the bitwise exclusive or. So both the bits are same. 1, 1, 0. 1, 1, 0. 1, 0. Bits are different now. So 1. 0, 0, 0. 0, 0, 0. So this is the result we are getting. Convert this into a decimal number. See what is the output I got? 4. 4 is the output I'm going to be getting. Let us confirm that. Okay, let us confirm that by running the program. So what am I going to do? I'm going to do copy this and convert this into a exclusive or the XOR. Run this. See what is the output we got. So this is how my bitwise and OR and XOR operators are going to be working. Right, is this clear? There you go. Okay, so this is the output we got. How we got the output, this is the explanation for us. Right, so bitwise and bitwise OR and bitwise XOR operator. The next operator is our complementary operator. So remember, complementary operator. The next three operators, complementary, left shift, right shift. I am going to teach you the shortcut method. No need to convert into decimal, binary, then again back to decimal. Nothing is required. We can directly work it out based on a shortcut method. So our complementary operator. Okay, our complementary operator. Okay, what is the shortcut? If the given number is positive, what will happen? Same way, if the given number is negative, what will happen? This is what we have to be looking into. What do you mean by this is, say for example, something like this. Something like this. I'm going to say done. So let us say, what is the complementary of 10? 10 is a positive number. Okay. What is the complementary of 256? What is the complement of 4589? All are positive numbers. Right. Now, let us try out for the other one. What if the given number is negative? Complement of minus 100. See what I'm doing? A minus. I'm giving a negative. Negative. So minus 10. Okay, so I have complement of positive numbers also. I can do the complement operator for a negative number also. So if the given number is positive, how the result is going to come? So please remember, result will be a negative value. If the given number is positive, result will always be a negative value. And how to calculate the result? Whatever is the given number plus 1, that is the result. So simple. Okay, whenever a positive number is given, result is going to be negative. Whatever is a given number plus 1. So here in our example, positive number, upper result negative. Again, this is also positive number, so result is negative. This is also positive number, result is negative. Now, what is the given number? 10. So, 10 plus 1, 11 is the result. 256 plus 1, 257. 4589, 4590. This is how the output will be coming. So, if the given number is positive, result will always be negative, and whatever is the given number plus 1. Same way, if it is a negative number, then result will always be a positive value. It's just the opposite. Remember, it is just the opposite. And whatever is the given number, minus 1. Whatever is the given number, minus 1. Say, for example, again. So I'm saying 100 minus 100. Upper result is positive number. So minus 100, 100 minus 1, 99. So here I'm saying minus 10. 10 minus 1, 9 plus 9. This is how my result will be coming. Let us cross check, run it. See what is the numbers you're getting. Same as what we predicted? Yes. That is how our complement operator is going to be working. So shortcut method to identify our the results of your complement operator, you can just do it like this. Okay, done.